This is some of what we did in the last chapter, right? This was on the test. How did we do this problem? Distribute. Yeah, we multiply these together like so. What is 3a squared times 2a squared?
6a.
Yeah, remember we just add those exponents, right? Plus 3 times 4 is 12. A squared times a to the third, minus 5 times 3. Okay, so that's what we did. This chapter that we're doing right now is kind of the opposite of last chapter. So last chapter we multiplied it together. This chapter we're breaking it apart. It's called factoring polynomials. You guys have heard this word before. You might have forgot what it meant. You guys know what factoring means?
Yeah.
Or what are factors? Let's say it that way. Factors of 20?
2, 5.
2 and 10. I always start with 1. Like 1 times 20. This is not really what we're doing in this chapter, but it's related to it. 1 times 20, 2 times 10. Does 3 work? No. 4 times 5. 5 we already have over here. So those are all the factors of 20. This times this, this times this, this times this equals 20. But in this chapter we're not doing factors of a number, we're doing factors of a polynomial.
So we
This
add it together and then find the factors of it?
Okay, good, hold on. So this times this equals this, right? So these are factors for this. So what we're doing is called factoring, but it's not factoring a number, it's factoring a polynomial. Okay, here's how we do it. Here's how it's going to work. Well, there's actually like 3 ways, but we're just doing the first way today. We look at all of our terms and we say, what can I divide out of all these? Or what goes into all these? What goes into 6, 12, and 15? 3. 3 is the biggest thing that can go. This chapter can be hard. Might be the hardest, actually. If you are good at your times tables, it makes it a lot easier.
I feel like you're looking at the same thing.
I'm looking right there. Yeah, no. I was just staring straight at the wall. So 3 goes into all these, but here's the other thing. What letters go into all these? Okay, A is partially right, but there's more.
B?
They all have at least a squared. A squared can go into all these. Here's a little bit of AC turned on for us. Okay,
+2.
basically you just use the smallest amount, the least amount.
Close.
Right? Yeah, I was going to say, I thought it was open.
No, that was.
There.
That's
That's close.
open. No, it's open.
I liked it better when it said something on it.
It's because it was
straight at
going
me.
He opened it all the way, so it's just going straight down. Okay. Anyway, what I was saying is a squared goes into all these because this is like a squared times 1, this is a squared times a, and this is a squared times a squared. So you just use the smallest of the a's, basically. All right. This comes out of all these. This divides out of all of these. So what you do is you put outside the parentheses. Inside the parentheses, you put what's left if I divide out 3a squared from all of these.
So it would just be a squared a.
Okay, this first term, what's 6 divided by 3?
3.
2. A4 divided by A2? Yeah, remember we just subtract the exponents here, 4 minus 3. 12 divided by 3? 4. A3 divided by A squared? And then minus 5. What happens to the A squared? They go away. This is it. Okay, this is called, well, I call it take stuff out. The book would call it like factor out a common monomial. I just call it take stuff out. Notice this answer is what I had to start with up here before we multiplied. This times this turns into this. So we're learning how do we turn it from the product back into the factors. We're going backwards. Take stuff out. Yeah.
Can we get the a squared again?
Okay, so 3 goes into 6, 12, and 15, right? But a squared goes into a squared, a cubed, and a to the fourth. Because this is a squared times 1, this is a squared times a, this is a squared times a squared. These are all divisible by a squared. Or you could say, you can take a squared out of all these. So basically just use the smallest one. We can't take a cubed out because there's not enough up here to take a to the third out. We can take an a out, but we can take more than a out. We can take an a squared out, divide a squared out. When I keep saying take stuff out, what I mean is we're dividing it out.
So we're taking the smallest.
Of the letters, yeah, you basically take the smallest of each kind. In this case, a squared was the smallest of the a's. Okay, this is like the final problem. It kind of starts off easier than that. So let's look at number 1. Should I do maybe one more and then call on you guys? Or does somebody want to volunteer right off the get-go?
I just don't know how to start it.
Okay, it's, you started by saying, what can I divide out of both of those? So, Allison, what goes into 8 and 80?
2.
1, 8.
You want to get the biggest number, by the way.
He said 1.
4 does work, but there's
Oh, wait, 8.
8's the biggest, yeah.
Ciao.
Okay, a lot of times, the thing that comes out, not always, is one of the numbers. Like the biggest thing that could come out of 8 is 8. And 8 does go into 80, so 8 does come out. Okay, what else are we going to take out? X. They both have at least an X.
Why do we keep the 8?
Dragon? What is 8 times 10?
Yeah, driven.
Okay,
What is 8 times 1?
8.
There you go.
What's that one?
so
What about
Draven, we're saying both of these are divisible by this.
Yeah.
We're kind of looking for like the greatest common factor. What's the biggest thing that can go into both of these? And the answer is 8. And as far as the letters go, the biggest X we can take out is just 1X because this has 1. Okay. Now, what we're doing, what we put in parentheses here is what's left after we take out an 8X. So instead of multiplying things together, we're dividing them apart. It's kind of the opposite of the last chapter. So basically what we're doing is dividing each of these terms by what we're taking out, 8X. What's this, Allison, what's this first term? 1X. So the 8 and the 8 cancel out, become a 1, but x squared divided by x is just x minus, what will this become? 10, what happens to the x's? They go away.
That's easy.
Do you know how we could check this problem?
Times 10 by 8 and 8 by
If you distribute this back together, it should turn back into this. That's just to check it. Okay. Claire, do you think you're ready? Who's throwing paper was? Oh, that's a card. Allison.
Well.
Show you magic trick when I give you an F on the 7th today. Oh.
As he does it.
All right. Claire, do you know what goes into both of these? 9 and 36? 9. What about the x's? How many x's can we take out? Just 1. Okay. We can't take out 2 because this only has 1. So, all right. What's left? What will the first term become when we take out a 9x? Well, the 9 divided by 9 is 1. X squared divided by x is x. Yes. 36 divided by 9.
Does
No, whatever it is, unless you take a negative out, which won't happen till the end. Yeah, it's kind of like distributive property in reverse, so whatever's in the middle is still in the middle. 11x squared minus 165x. Alright, Kinsey, what do you think we can take out on this one?
That's a really
Well,
good
what's the only thing that goes into 11? 11 times 1. Now taking a 1 out, dividing by 1 doesn't do anything, so you can't really take a 1 out. But if anything goes into these, it's going to have to be 11. So I would try dividing that by 11, and of course it works. Okay, 11, and what else can we take out?
It's 11x.
X.
Is x minus 17.
You guys starting to feel the pattern here? Of course, once we start getting comfy, the problem's going to change a little bit. But you guys like the challenge. About the time we get to the drive, and it's going to switch up. All right, Eleanor, what do you think? What comes out of both of these? 11 and M. What's going to be left? You don't have to write this little visual down here, but I'm showing you what we're doing. We're dividing 11M out of both of those. Yeah, that's right. Do you guys remember the nines trick to check, not to remember how to multiply by 9, but to remember how to see if 9 can go into something? Yeah, you add the digits. 1 plus 5 plus 3 is 9. Does 9 go into 9? Yeah, so 9 does go into 153. That also works with, oh, I thought that was like a 7th grade trick you were supposed to learn, but maybe you didn't. Well, it's not like a have to know thing, but it's just handy. That trick also works with 3s, by the way. Okay, so, Bella, what goes into both of these?
9a.
9a. And,
17.
yeah, so she had to do 153 divided by 9 to figure out where, that's where she got the 17 from. Now, it could be nothing could come out. I mean, on this worksheet, there will be something to come out, but possibly it's nothing.
Wait,
Oh,
will you go for like 2 seconds?
That reminds me. We need to talk about this one before we see it. Okay, everybody, what comes out of both of these? 2 and a squared. Okay, if I divide this by 2a squared, I get 2a. But what if I divide this by 2a squared?
No, because it's a negative.
Okay, it does cancel out, but what's left? 1. So like 2 divided by 2 is not 0, it's 1. So it's never going to be like 0 over here. It's going to be at least a 1. Does that make sense? That'll show up in like 5 problems or so. I just want to warn us before we get there. Number 11. All right, Pearson, guess what goes into those two? 6 and V. So what's going to be the leftover?
3 plus 16.
Yeah. You guys remember short division? Have you guys done that?
I do.
Probably since you got the calculators, you stopped doing it, right?
Yeah.
Calculators make us dumber. Alright, it's starting to change a little bit on the back. Just a little bit at a time. Alright, Draven, what do you think?
I say we divide them both by
4 and?
Y.
Well,
X.
yeah, this one doesn't have a Y, but they do both have an X. Okay, what's gonna be left? What's gonna be left over here? X squared divided by X? It's kinda like 2 minus 1, just leaves 1, X. Okay, how about over here? That was 8?
8 Y.
Yes. Yeah, the X's went away, but there's still a Y left on this one.
Wait, so like on number 14 it says NA, so and it has NA on both, so we would just do one.
Yep. Okay, A squared plus 9AB. Let's see, we're Whitworth. What can we take out of both of those?
Or just, yeah, well. But it'd just be like
Yeah. Taking a 1 out is the equivalent of doing nothing. So, because dividing by 1 doesn't change anything. So, it's never just take a 1 out. But yeah, we can take a A out. And what would be left if we take an A out?
A plus 9B.
Alright, Trident, what do you think we can take out of these two? They both have what in common?
X.
X what? How many X's can we take out of both of them at least? 3. Because this one has 3, this one has more than 3. So we can take out at least an X cubed from both of them. Okay, what's going to be left after we take out X cubed?
Y.
On the second part, this will be a Y. But what about this first one?
X. A 1.
Yes, X to the 1, which is just X. So, and then you said the second part. So it's X minus Y. $19.
What if like on like number 20 it says P squared Q and then it's like PQ squared, but it just be PQ that you
Yeah.
take out?
Yeah, they both have at least a P, they both have at least a Q. And they both have at least 5. Alright. Katie, what comes out of these two?
5.
5, and? They both have at least what?
Q.
Q. Alright, so what's going to be left if I divide the first term by 5Q?
2.
Well, that goes away, that goes away. So P squared. Okay, I think you were looking at this one, weren't you? Because what's going to be left on this one?
Yeah.
Huh?
Yeah. 2.
2.
Oh, we have algebra today.
Yeah, it turns off and on. It'd be nice if it just stayed on for a while. getting messier. Luke, what do you think we can take out these two?
5
And?
AB.
Does it matter since the 5's after? Like, since it's 35 and then 5, would it change anything or not? Okay.
Doesn't matter. Alright, what is going to be left, Luke, after we kick the... Yuck.
AB minus 7.
Okay, I talked about this earlier. What happens when you do 5ab divided by 5ab?
Oh, it turns into AB squared.
No.
Or plus
Anytime you divide, like what's 5 divided by 5?
1.
1. Anytime you divide something by itself, it's not 0,
It's 1.
it's 1. Okay, something is a little bit wrong with this though. Forgot to divide this. You got 7 on the front.
Oh.
Okay, 23.
I don't like number 22.
Yeah, that's the one the other class complained about the most, I'd say.
Have y'all seen 22? I don't like it.
That's my favorite. Alright, where are we at? Hallie. Okay, let's start with the numbers. Hallie, what goes into 6, 10, and 2? 2. Okay, and then as far as the W's go, they all have at least how many W's? 1. Alright, so we're taking out 2W from each of these, dividing them out. So, yucky. What's going to be 3? 3 what? W. Okay, so for the division with the same variable, you just subtract the exponents. Since this doesn't have an exponent, that means the exponent is 1.
So 3.
Yeah, so it's W cubed. Yep. Okay, and how about the second one, Allie? Yeah, minus 5, what? Yep. Okay, and the last one? Well, it'd be like W0, which is just kind of goes away. So, yeah, 2 divided by 2 is just 1, so it's just a 1. Alright, did we finally make it to the end? Everybody kind of got one. Or Allison kind of got 1.5. Negative 3 p to the 4th. If Wyatt would have been here, it would have been right. Alright, Allison, what can we take out of this? Huh? Yeah. You could take out just a normal 3. Yeah, let's go ahead and take out a negative 3. That might make it a little more confusing taking out a negative, but we'll look at it. Okay, and then how many p's can we take out? They all have at least how many p's? 1. We can't take out 2 because there's only 1 in this one, right? Yeah, so they all have at least 1 p. 1. Okay, so what we're taking out is negative 3 to the p. We haven't taken the negative out yet. Normally you don't, probably wouldn't, but this is the one problem you might want to. Okay, so what's this first term going to become? 1 p cubed, or just p cubed. Okay, the middle term? Yep, minus minus 5p. You could put plus negative 5p, but I wouldn't. I would just put minus 5p. And the last one?
Just minus 2.
Minus 2. So how about I check your number 2, and then maybe a hard one on the back later on. So everybody try number 2. We'll see how this goes. Don't tell me you're done